Hi, my name is Delniza Anadisman and my matrix number is 87143. This is my final year project Fyp1 Presentation. So my project is titled NutriScan, a mobile solution for simplifying nutrition label interpretation using OCR. So my FYP supervisor is Dr. Chai Susi and my FYP examiner is Dr. Bong Chi Hao. So I will be presenting my introduction, background, problem statement, objectives, scope, literature review, and methodology used for my project. Malaysians today rely heavily on packaged and processed foods because of convenience. However, the nutrition labels on these products are often complex, filled with technical terms and numbers that are difficult for ordinary consumers to understand. This has contributed to rising health issues such as obesity, diabetes, and hypertension, which make it important to have a simple digital solution. There are existing applications like Yuka, BiteSight, and What to Eat, but they have limitations. Most required manual input are based on international dietary standards and don't apply to Malaysian dietary guidelines. This means they are less effective for local consumers. NutriScan was developed to address this gap. It is a mobile application that uses optical character recognition or OCR to automatically extract nutrition information from food labels. The system then applies rule-based classification to categorize products as healthy, moderate, or unhealthy. The app also provides a clear breakdown of key nutrients such as calories, sugar, sodium, and fat. Users can save their scanned products and view their history, making it practical and user-friendly. For development, I use the rapid application development methodology, which focuses on iterative prototyping, continuous testing, and user feedback. This ensures the application is reliable and meets user needs. Overall, NutriScan aims to simplify nutrition label interpretation, promote healthier eating habits, and support Malaysia's public health initiative. In Malaysia, many people rely on packaged and processed foods because they are convenient and easily available. However, the nutrition labels on these products are often difficult to understand. They contain technical terms, different measurements, units, and dense numerical data, which makes it confusing for ordinary consumers. As a result, many individuals struggle to interpret whether a product is healthy or not, and this can lead to poor dietary choices. This issue is particularly concerning because Malaysia is facing rising of prevalent non-communicable diseases such as obesity, diabetes, and hypertension. Although nutrition labels are regulated and provided on most packaged foods, many consumers simply don't have the time or awareness or expertise to evaluate them properly. Therefore, there is a clear need for a practical and accessible digital solution that can simplify nutrition information. This is where NutriScan comes in. The application uses optical character recognition (OCR) to extract nutrition data directly from food labels and apply rule-based classification based on the Malaysian Dietary Guidelines 2020. By doing this, NutriScan provides clear and actionable insights that help consumers make healthier food choices. In today's fast-paced lifestyle, many people rely on packaged and processed foods because they are convenient. Although nutrition labels are provided, they are often presented in complex formats with technical terms, varying units, and dense numerical values. This makes it difficult for ordinary consumers to interpret the nutritional quality of the products they consume. As a result, individuals may unintentionally make poor dietary choices, which can negatively affect their health. This challenge is especially concerning in Malaysia, where diet-related health issues such as obesity, diabetes, and hypertension are on the rise. Despite growing awareness of healthy eating, many consumers lack the nutritional knowledge or the time to manually evaluate labels during food selection. Existing applications also have limitations. They often require manual input, advanced nutritional understanding, or not tailored to Malaysia dietary guidelines, which reduce their effectiveness. At the same time, mobile devices present an opportunity to leverage technology. However, many current nutrition apps do not fully utilize automated techniques like OCR to extract information directly from food labels. Instead, user must enter data manually, which is time-consuming, inconvenient, and prone to error. Another gap is the lack of localization. Most apps do not apply a Malaysian Dietary Guidelines 2020, meaning their classification may be inaccurate or less meaningful for local consumers. Therefore, there is a clear need for a mobile application that can automatically extract, analyze, and categorize nutrition label information using OCR and rule-based logic aligned with Malaysian dietary guidelines. Such a system can classify food products as healthy, moderate, or unhealthy, while presenting clear and understandable nutrition insight. This will help promote healthier eating habits, enhance nutrition awareness, and support informed dietary decision making among consumers. The objective for this project is to develop a mobile application that enables users to capture or upload nutrition label images from Malaysian packaged foods, to implement an OCR engine to extract and process nutrition information accurately from the captured or uploaded image. Thirdly, is to design and apply a rule-based classification system to categorize products as healthy, moderate, or unhealthy based on the Malaysian Dietary Guidelines 2020. Lastly, is to store users' scan result and nutrition information in a structured database for reference. The scope of my project is to develop a mobile application that focuses on Malaysian packaged food labels. The system uses optical character recognition (OCR) to extract nutrition tags from images that user either upload or capture. Once the data is extracted, the application applies a rule-based classification system to categorize products as healthy, moderate, or unhealthy, based on the Malaysian Dietary Guidelines 2020. To support this, a database is built to store scan result and nutrition information, while a user-friendly interface ensures that the results are presented clearly and easy to understand. The accuracy of both OCR extraction and classification will be tested using a dataset of 200 to 300 nutrition label images. Ultimately, the final system will allow users to make more informed dietary decisions by providing transparent and accessible nutrition insights. And now we will move on to literature review, which is the comparison between NutriScan with existing application. This table provides a quick overview of four nutrition-related mobile applications: Yuka, BiteSight, What to Eat, and NutriScan. It compares their platform availability, core features, and regional relevance. As you can see, each apps offer different strengths. Some focus on barcode scanning, others on nutrition scoring or explanation. However, only NutriScan is fully tailored to Malaysian users, with localized standards, OCR support, and health category classification. I'll now go through each application one by one to explain these differences in more detail. Now I will present a comparison between three existing nutrition applications: Yuka, BiteSight, and What to Eat, and my proposed application, NutriScan. First, Yuka mainly relies on barcode scanning and gives health score from 0 to 100 based on European nutrition standards. It also provides explanation and nutrient breakdowns. However, Yuka is not available in Malaysia and does not support OCR, and it lacks a clear health category classification, which makes it less useful for local consumers. Next, we have BiteSight. BiteSight focuses on OCR-based ingredient scanning, allowing users to capture nutrition labels directly with their camera. It provides explanation but does not give a nutrition score, nutrition breakdown, or health classification. The app is free on Android but require payment on iOS, and it is tailored to US nutrition formats, which limits its relevance for Malaysian users. Then we have What to Eat. What to Eat combines barcode scanning with image-based food recognition to generate an A to E grading system. It also provides explanation and nutrient breakdowns. However, its OCR capabilities are limited and less reliable. It is restricted to iOS and it relies on Western dietary guidelines. It also does not classify food into health categories and has limited user history tracking. Finally, we have NutriScan. NutriScan addresses these limitations by incorporating OCR tailored to Malaysian nutrition labels. It provides nutrition analysis and breakdown, aligned with Malaysian dietary guidelines, and uses a rule-based classification system to categorize products as healthy, moderate, or unhealthy. NutriScan allows user to store scan history and offers partial offline functionality. Most importantly, it is region-focused, fully adapted to Malaysian packaged foods, and provides localized nutrient evaluation. In conclusion, while Yuka, Bite and What to Eat each have useful features, they lack localization, reliable OCR, and clear health classifications. NutriScan fills this gap NutriScan fills this gap by offering a Malaysian-focused solution that is automated, accurate, and user-friendly, making it the most suitable option for local consumers. For this project, I applied the Rapid Application Development or RAD methodology. RAD emphasizes fast prototyping, iterative testing, and continuous user feedback, which make it suitable for mobile application development. Let me walk you through the four phases. Phase 1, Analysis and Quick Design. In the first phase, I identified the project objective, scope, and system requirements. I collected information from Malaysian packaged food labels to determine the necessary functionalities, such as OCR extraction, classification, and data storage. A brief interface layout and system design were also drafted to visualize the overall structure before moving into prototyping. Phase 2, Prototype Cycle. In the second phase, functional prototypes were developed, including the OCR module and classification logic. These prototypes were demonstrated, tested, and refined based on feedback. The cycle of development and improvement continued until the intended accuracy and usability standards were achieved. The third phase is the testing phase. In the third phase, the system underwent comprehensive testing. The rule-based classification was validated against the Malaysian Dietary Guidelines 2020, while the OCR feature was tested using 200 to 300 nutrition label images. Any issues found were corrected to ensure the system's reliability and performance. The last stage, the last phase is the deployment. Finally, in the fourth phase, the completed mobile application was deployed for actual use. It was tested on real devices to evaluate efficiency and user experience. Documentation of the development process, testing results, and performance was also prepared for final submission and presentation. In summary, RAD allowed me to iteratively build, test, and refine NutriScan, ensuring that the final application met both functional requirements and user expectations. Now I'll present how user feedback from the questionnaire directly informed the design of NutriScan features. This table shows the alignment between what users want and how the system responds to those needs. First, 73.5% of respondents said that they want the ability to scan labels using camera. To meet this need, NutriScan includes an OCR scanning features that allow users to capture label images directly. Next, we have 63.3% wants an automatic health categorization. NutriScan addresses this by classifying products into healthy, moderate, or unhealthy categories based on Malaysian dietary guidelines. 59.2% of respondents wanted detailed nutrient analysis, so the system provides a clear breakdown of key nutrients including energy, sugar, sodium, fat, and fiber. 34.7% of users asked for the ability to self-scan products. NutriScan includes a save product features with history tracking so users can revisit past scans. Interestingly, 71.4% of users said they check sugar content most often. To support this, NutriScan highlights sugar values prominently in its analysis interface. 49% of respondents use nutrition label information when selecting products. To make this easier, NutriScan simplifies label interpretation into a format that's easy to understand. Finally, 61.2% of users said reading labels is time consuming. So NutriScan solved this by offering a quick visual indicators that help users assess product healthiness at a glance. In summary, every major features in NutriScan was designed based on actual user preference. This ensures the application is not only functional but also relevant and user-friendly for Malaysian consumers. Next, I'll explain the key software tools used to develop the NutriScan mobile application. Each tool was selected to support specific technical function and ensure smooth performance. First, Android Studio. This is the official integrated development environment (IDE) for Android development. I use it to design the user interface, write and debug code, manage dependency, and test the application using virtual Android devices. It provides a complete environment for building and refining the NutriScan app. Secondly is the Room database, which is built on SQLite. Room acts as a structured local database within the app. It stores all extracted nutrition label data, product information, classification results, and scan history. This ensures that users can access their data even offline, and it improves the app's performance and reliability. Third is the Google ML Kit, the text recognition. This tool powers the OCR features in NutriScan. It automatically detects and extracts text from nutrition label images captured by the camera or uploaded from the gallery. This allows the system to process the nutrient values accurately and classify products based on Malaysian dietary standards. Together, these tools enable NutriScan to deliver a seamless experience from scanning, analyzing labels to storing results and supporting informed food choices. Next is the hardware tools used during the development and testing of NutriScan mobile application. First, the laptop. I use the Acer Nitro 5 equipped with a 10 Gen Intel Core, i5 processor, NVIDIA GeForce GTX graphics, sufficient RAM, and adequate storage. This setup provided the performance needed for coding, debugging, and running Android Studio efficiently during development. Secondly is the Android Secondly, the Android device. For testing, I use the Samsung Galaxy J8 powered by a Qualcomm Snapdragon 450 chipset with an octa-core CPU and Adreno GPU. This device was suitable for testing key features such as image capture, OCR functionality, and overall usability of the NutriScan app in the real-world mobile environment. Together, these hardware tools ensure that both the development and testing phase was smooth, reliable, and reflective of actual user conditions. As shown in the figure, the workflow of the proposed nutrition label scanning applications begins with the user either scanning or uploading a nutrition label. This stage employs OCR to extract text from the image in real time. If the text extraction fails, the system prompts the user to rescan or re-upload the label to ensure accuracy of the information provided. Once the text has been successfully extracted, the application proceeds to analyze the nutrient content by referencing key values such as calories, sugar, sodium, fat, and fiber. Based on this analysis, the product is categorized as healthy, moderate, or unhealthy, or unknown. For product classified as unknown, the system requires the user to rescan or re-upload the label to improve reliability. Following categorization, the application generates a clear explanation of the assigned category along with a detailed nutrient breakdown. These results are then displayed to the user, enabling them to make informed dietary decisions and enhance their overall food selection experience. The process concludes with the option to analyze another product or exit the application. The process flow of the proposed nutrition label scanning application begins when the user launches the app and activates the camera to scan a product's nutrition label. The system then extracts text from the image using OCR. If the extraction fails, the user is prompted to rescan the label to ensure accurate data capture. Once the text is successfully extracted, the application is proceed to analyze the nutritional content, referencing key indicators such as calories, sugar, sodium, fat, or fiber. Based on the analysis, the app assigns a health category such as healthy, moderate, or unhealthy, or unknown, which is then displayed to the user. Following this, the system provides a category explanation and a detailed nutrient breakdown, allowing users to better understand the nutritional profile of the scanned product. This structured process supports informed decision making and enhances the user experience by combining real-time scanning with simplified nutritional insight. As shown in the sequence diagram illustrates that the interaction between the user and three core systems, which are NutriScan, Google MLKit, and SQLite during the nutrition level analysis process. The workflow begins when the user initiates a scan or uploads an image of a product nutrition label. NutriScan then processes the image using Google MLKit, text recognition capabilities to extract relevant information. Upon successful extraction, NutriScan parses the recognized text, applies the classification rules, and queries the SQLite for persistence and retrieval of scan records. MLKit does not interact with SQLite. This category is returned to NutriScan and displayed to the user. Subsequently, NutriScan retrieves additional nutritional data from SQLite, including a category explanation and a detailed nutrient breakdown. These outputs are presented to the user in a structured format, enabling informed dietary decision. The diagram highlights the systematic exchange of data between machine learning and database components, ensuring real-time feedback and personalized nutrition insight. This classification rules table shows how NutriScan classify fruit products based on five key nutritional parameters, which is energy, sugar, total fat, sodium, and fiber. Each product is categorized as healthy, moderate, or unhealthy depending on the nutrient values. Let's start with the healthy categories. So, to be considered healthy, a product must contain 150 kilocalories or less per serving, 5 grams or less of sugar per 100 grams, 3 grams or less of total fat, 120 milligrams or less of sodium, and at least 3 grams of fibers. Next is the moderate category, which includes products with 151 to 250 kilocalories, 6 to 10 grams of sugar, 4 to 7 grams of fat, 121 to 200 milligrams of sodium, and 1 to 2 grams of fiber. Finally, the unhealthy categories applies to products that exceed this threshold: more than 250 kilocalories, more than 10 grams of sugar, more than 7 grams of fat, and more than 200 grams and milligrams of sodium, and less than 1 gram of fiber. This classification system is based on Malaysian dietary guidelines and recommended nutrient intakes, the RNI, ensuring that NutriScan provides localized and meaningful health evaluations. It helps users quickly understand whether a product supports healthy eating habits or should be consumed in moderation. This class diagram illustrated the back-end structure of the NutriScan application, modeling the interaction between user, scanning processes, OCR functionality, database management, and the nutrition analysis. The user class initiates actions such as scanning, uploading, and saving, and viewing history. These actions are processed by the scanner class, which connects to both the OCR processor for text extraction and the database manager for storing and retrieving scan data. Extracted text is analyzed by the nutrition analyzer, which identifies nutrient values and generate insight based on the nutrition data class. The relationship between classes are clearly defined, supporting a modular and traceable architecture that aligns with NutriScan's core functionality and integration with tools like Google MLKit and SQLite. This use case diagram illustrates the functional requirement of NutriScan application, highlighting how users interact with the system and how external components support its processes. Core user actions include scanning or uploading nutrition labels, viewing product categories, analysis breakdowns, and accessing scan history. These actions are supported by back-end processes such as OCR extraction via the Google ML Kit, nutrition analysis, product classification, explanation generation, and data storage or retrieval through SQLite. The diagram clearly shows the relationship between user-facing features and system operations, providing an overview of how the application delivers nutrition insights in a structured and user-friendly manner. This is the proposed homepage. It displays the main interface of NutriScan mobile application, designed to simplify nutrition label analysis. It features three central user options includes upload label, scan label, and view history. Each feature accompanied by intuitive icons for ease of navigation. The layout is minimalistic and user-friendly with a clear note indicating that the app is tailored to Malaysians nutrient standards (RNI), reinforcing its localized dietary relevance. This proposed UI represents the nutrition analysis and nutrient breakdown screen of the NutriScan mobile application, which evaluates a product nutrition levels. The product is classified as healthy, as you can see, indicated with a green check mark symbol, supported by the explanation such as low sugar content and minimal fat and sodium. A nutrient breakdown is displayed using color-coded bars to highlight energy, sugar, and sodium content, which easy to interpret. The interface also provides option to save the product or exit and notes its alignment with Malaysian Nutrient Standards (RNI), reinforcing its localized dietary relevance. This UI displays the NutriScan app's history screens showing a previously scanned product labeled as healthy with a green check mark and the date 25th December 2025. A small preview of the nutrition label is included, and the interface offers an exit button. The footer notes that the app is designed according to the Malaysian Nutrient Standards (RNI), reinforcing its localized relevance for dietary assessment. So to conclude everything up, NutriScan is a mobile application designed to help users understand nutrition information on packaged food products more easily. The application allows users to scan and upload image of food nutrition labels and extract nutrition lab data using the OCR technology. The extracted information is then analyzed using the rule-based logic based on the Malaysian Dietary Guidelines 2020 to classify products as healthy, moderate, or unhealthy. NutriScan also provides a clear nutrition breakdown and allows users to save scanned products and view their scan history, supporting informed and healthier dietary choices. By offering a user-friendly interface, NutriScan seeks to promote nutrition awareness and encourage healthier eating habits among Malaysian consumers. This project not only addresses the challenges of interpreting nutrition labels, but also supports informed dietary decision making by accessible mobile technology. And that's all from me. Thank you.